Hello everyone, and welcome. Have you ever wondered how scientists can figure out what a distant star is made of, or identify a specific molecule in a tiny drop of liquid without ever touching it? The secret often lies in a powerful set of techniques known as scattering spectroscopy. Today, we're going to break down this complex-sounding topic into something simple. Think of it like this. Imagine you're in a dark room and you want to know the shape of an object you can't see. You could throw a handful of tennis balls at it and watch where they bounce off. By observing the angles and speeds of the scattered balls, you could piece together a mental image of the object's size and shape. Scattering spectroscopy works on the exact same principle, but on a much smaller scale, using particles like light, called photons, instead of tennis balls. We shoot a controlled beam of these particles at a material we want to study. Then, we use sensitive detectors to watch how these particles scatter in all directions. This scattered information is a treasure trove of data. The key is to look at two main types of scattering. First, there's elastic scattering. This is like a perfect bounce where the light particle hits the sample and changes direction but doesn't lose any energy. A famous example is Rayleigh scattering, which is the very reason our sky is blue. This type of scattering is great for telling us about the size, shape, and structure of particles. The second, and often more revealing type, is inelastic scattering. In this case, the light particle actually exchanges a tiny bit of energy with the sample when it hits. It might give some of its energy to a molecule, causing it to vibrate, or it might steal a bit of energy from a molecule that's already vibrating. By precisely measuring this tiny change in energy, we can get a unique chemical fingerprint of the material. A famous example of this is Raman spectroscopy, which can identify molecules with incredible accuracy. So, whether it's elastic or inelastic, by analyzing the angle, intensity, and energy of the scattered light, we can learn about a material's composition, its atomic structure, and even how its molecules are moving. It's a non-destructive way to see the unseen, used everywhere from developing new medicines and creating advanced electronics to analyzing ancient artifacts. And that's a quick look at the fundamental idea behind scattering spectroscopy. Thank you so much for watching. If you found this explanation helpful and want to learn more about the amazing world of science, please consider liking this video and subscribing to support the channel. It truly helps us create more content for you. We'll see you in the next one.